In this module, I'll walk you through what it is to be a Ramsey sentence and what it means to be a Ramsey correlate. I'll do that using model theoretic formalism, which you're probably not very familiar with, but hopefully I can give you the basic gist of what's going on. So how do we create a Ramsey sentence for a theory? Well, we can use Bloch's example of a theory of pains and proceed as follows. First, we can join all the laws of our theory. Now, this glosses over some details in Ramsey, but that's okay. There's not that much that's important there. So that theory of pain that Bloch gave us is pain is caused by pinpricks. So we can join that with pain causes the emission of loud noises, and pain causes worries, and worries cause brow wrinkling. Once we've created our theoretic conjunction, one of the things we might notice is the difference between the kinds of predicates that get used in our theoretical statements. Some of them, the ones in blue, are theoretical terms. They refer to mental states, pain and worry. Others are observation terms. They refer to things that are part of our ordinary experiences in the world that we can see or touch or smell or feel. Now, suppose that we're really cautious and we don't want to commit to anything over and above the stuff that we can see and smell and touch and hear, but we want to understand what our theory means by pain or what our theory means by worry. Well, if we're descriptivists, we can do that by creating a Ramsey sentence for that theory. And what a Ramsey sentence does, in effect, is it allows us to create a definite description, a set of relationships between theoretical terms and observation terms, and theoretical terms, without committing us to any specific details about the theoretical entities beyond what our theory says about their relationships to observation and to each other in the abstract. So we relate our theoretical lexicon or language, pains and worries and so on, to our observational lexicon or language, pinpricks, the emissions of loud noises, brow wrinkling, that allows us to understand those theoretical terms without importing in anything more than the relationships and the observations that are implied by our theory. So let's see how that works. So our next step then is to take that conjoined theory and then get rid of all those theoretic terms, get rid of the theoretic language. And we do that by substituting in existentially quantified variables for each of those mental terms, each of those theoretic terms in our original theoretic conjunction. So our new T then says, T claims that there's at least one thing, x1, and at least one thing, x2. x1 is caused by pinpricks, and x1 causes the emission of loud noises, and x1 causes x2, and x2 causes brow wrinkling. That's what our theory tells us about the world. Once we get rid of all that theoretic language and just talk about the relationships between the posited entities, whatever they might be, and our observations. And so now we're in a position to understand what it would mean, given our theory, to say that someone is in pain. To say that someone is in pain is to say, look, if we were to go out into the world and we were to find somebody, say Bob, and Bob says he's in pain, I have pain, then what would that mean? Well, that would mean that there's at least one thing, call it x1, and at least one thing, call it x2. And x1 is caused by pinpricks, and it causes the emission of loud noises. And x1 causes x2, and x2 causes brow wrinkling, and Bob has x1. So Bob's got a thing that satisfies all of those relationships between observation terms and between all the other terms. Now, there are a couple more points we want to make before we move on. That first sentence, T equals there is at least one thing, x1, and so on, that is our Ramsey sentence for that theory. It is the expression of the relationships between these variables and our observation terms that we can then use to talk about what the theory is asserting about the world. The second sentence, Bob has a pain, that is a Ramsey correlate of our theory of that first sentence. sentence. But it's not any old thing that Bob has if it's going to be a Ramsey correlate. Our interpretation, the way that we make our theory true or false, the way that that second sentence becomes true, is if Bob maps onto an individual from our observation language, that is our ordinary objects, and has as a relationship that we can understand within our object language. And P now maps onto something else in our object language, C fibers, for example. So Bob has pain is a Ramsey correlate if that theoretical relationship can get cashed out via our Ramsey sentence being interpreted on our object language, mapped onto the world in such a way that everything in that sentence is true and Bob has got that thing. Now you might be thinking, oh, thank God that's over. Well, not quite though. We can define pain itself. That is, we can say what it is to be a Ramsey correlate of this formula for that particular theoretic term in the following way. We define an operator, phi I of x1 for some formula, and we define it to mean the property of being a member of the substitution class for x1 in that formula f that makes f true for all the different substitution instances of those types for x1 and x2, such that those substitution type instances are proper subsets of our observation language. That is, I.O. specifies the standard interpretation for our observation terms like pinpricks. Now you might say, that sounds awful. And that sentence that follows it looks even worse. Pains are by definition the phi I of x1 such that there's at least one x1 and at least one x2 such that it satisfies all the sentences of our theory. Now you might say, I don't really know what that means. If you are confused, give me 2 more slides and see if I can't clear things up for you. So let's take what we just wrote down in this formalism and translate it to sort of English. We might express that definition in the last slide in our sort of English as follows. Pain is such that for anything that can have it, there is some set of states that when mapped onto the variables of the theory, satisfy all the laws of the theory, and pain is the state that occupies that specific role x1 in this mapping. Or more technically maybe, pains are any kinds that occupy that role x1 in any model of the theory. For example, if stimulated C fibers occupied that role in humans, they would count as pains. If high brachial activity occupies that role in octopi, it's pain. Now, if you're still feeling a little bit confused, or if you just like to rehearse this a little bit more, let's look at this next slide. So suppose we decide we're traveling on the road with Frank Ramsey, and we're going to play a game, the Ramsey equivalent of 20 questions or I Spy. So Ramsey will give us these Ramsey correlate definitions of a coin that's in a box in the front seat there. And we have to look at those definitions and decide what coins could possibly be the coin that's in the box. So our first Ramsey correlate definition there, C1, says our coin is by definition the phi interpretation of x1 such that there's at least one coin x1 and at least one coin x2, and x1 is silver, and x1 works in vending machines, and x1 is worth more than x2, and x1 is lighter than x2. So now we say, okay, that definition has got to pick out one or possibly more different kinds of coins. So let's see, coins that work in vending machines that are silver, nickels, dimes, quarters, dollar coins. Those 4 definitely going to be candidates. They're all silver. They all work in vending machines. X1, the coin we're trying to guess, it's worth more than X2. So it can't be the nickel now. That's the least valuable. And X1 is lighter than X2. So X1 is worth more, but it's lighter than X2. There's only one coin that's worth more than another coin that is also lighter than that coin and is silver and works in a vending machine. That means our coin has to be a dime. It's got to be a dime because dimes are worth more than nickels and dimes are lighter than nickels and dimes are silver, and dimes work in vending machines, and none of the other coins satisfy all the laws of our coin definition theory. Let's look at C2 then. Ramsey changes it up a little bit, and he says, okay, our coin now by definition equals the phi interpretation of x1 such that there's at least one coin x1 and at least one coin x2, and x1 is silver, and x1 works in vending machines, and x1 is worth more than the other coin x2, and x2 is lighter than x1. I mean, okay, so everything's the same right up until that last rule. And that last rule says that the coin that is worth more is also the heavier coin. So it can no longer be the dime and the nickel anymore, and it can't be the nickel to the dime. It's got to be either the quarter or the dollar coin. The quarter would be worth more than the dime or the nickel and heavier than the dime or the nickel. So it could be the quarter in one of those. Or it could be the dollar coin and the nickel, the dime, or the quarter, any of them. So it's got to be one of those two, but nothing about the theory specifies that it's the quarter or that it's the dollar. So this is a multiply realized predicate, our coin predicate here. It could be quarter or it could be a dollar. Either one of them satisfies our definition.